Welcome everyone. I'm Drew Vry, and today we're going to be going over a webinar about data analysis. So let's get started. Data analysis importance. Data is money in today's economy. It is the biggest asset for huge tech companies like Google, Amazon, Facebook, Yahoo, etc. It helps businesses improve specific aspects about their products and services, and it has a high growth job segment. Data is one of the most important and crucial things out there today and is extremely valuable. Impact on society. Government policies based on consensus data analysis. Potential to impact opinions of large populations by messaging directly to targeted people. For example, Facebook's impact on the presidential election. Ability to swing sentiments through social media. Data science is used for analyzing medical images, genetics, and genomics. It is also applicable to the development of drugs as well. It can detect risks and frauds in the financial sector. And as time goes on, data just becomes more and more valuable and important. What is data? Data is information that can be collected, sorted, and analyzed. And even though people have been placing heavy importance on data in recent times, data has been around for a really long time in our history. As you can see in the first picture over here, we have prehistoric times where people just have engravings and pictures on the caves, which is also considered data because once again, it's information that is collected, stored, and analyzed. Even though that's not what you typically might think of when someone says data, that still counts. And then other examples of data are Weather Watch, which is one of the more common examples, and even things like sports scores. For example, in a basketball game or a baseball game or anything, the live scores are collected, stored, and analyzed. So that is data. What is data analysis? Data analysis is defined as a process of collecting, cleaning, transforming, and modeling data to discover useful information for business decision making. Through data analysis, you can also detect weaknesses and strengths of your competition, uncovering opportunities for improvement. Analyze online reviews about your competition to answer questions like, what do your customers love or hate about your competitors' products or services? What is data analysis? It is the process of extracting meaning in data, and it involves the following steps: data collection, data cleaning, data grouping, data aggregation, and data visualization. The goal of the above five steps is to include one or more of the following: understanding past and current scenarios, which shows what has already happened, future projection, which predicts what might happen in the future, discovering valuable insights, or like revealing some hidden features that were unexpected or not directly visible without data analysis. Data collection. This is the first step in analysis, and we need to focus on items like, is the data already available in the organization? Do we need to merge data from different sources? Are there legal requirements to be met? An example for this point would be privacy laws that tell who can gather data for how long, etc. Do we have or can we get all the data that is needed? Sometimes we may not be able to collect everything that is needed based on time, valuable, cost, expertise, etc. Are the data in the same format? For example, Excel, CSV, database tables, JSON, different time zones, encoding, etc. Data cleaning. Once we have the data that we may need to make sure the data set has relevant data only. Once we have the data, we may need to make sure that data has only relevant data. for which we can look at things like, is the data well structured with well defined fields? Can we easily merge data from all sources? Are we missing any values or is there any data gap? For example, a time series data maybe missing a few dates or few months, or sales data maybe missing one segment. Is there granularity by date, by products, etc., across all data sources? Do we need to keep data updated frequently? Does the data get stale? Before we move on to any next steps, we may need to remove inconsistent and superfluous data from the set and remove some outliers. Interpretation or visualization. Once our data is cleaned, we can start the data analysis. We can draw meaningful and actionable insights, create visualizations to show results. The data must be easy to comprehend. We should not need to do a data analysis on a data analysis to find understandings of it. It must be actionable. If the analysis shows something which we cannot stand upon, then it is not worth doing. Use dashboard or storytelling to convey the findings. So data visualization is a really important part because sometimes when you have a table with a lot of numbers, it's hard to see any trends or anything simply by looking at the numbers. The human brain can't simply process so much information like that. It'll look simply meaningless. But then if you group those numbers together and put it in a visual representation, for example, a chart or a time series graph or something like that, then you can see a trend or a line that's easier to analyze, and you can hopefully notice patterns much easier. What is the need for data analysis? It turns data points into meaningful insights. It highlights areas for improvement. It reveals the best directions for organizations. It shows future trends and measures the impact of marketing outreach. One example of success data driven product is the Google Nest. It collects, analyzes, and learns from data to improve its usability. So here are some use cases. Market research. How much of a market share the company has, which area the company needs to focus on. Product research. Is the product needed by customers? Which features of products are being used more? Customer reviews. What customers liked or disliked. Sentiment sentiment analysis. Reactions of customers to promotions, company initiatives, and tweets. Competitive analysis. Who are competitors and what are their competitive offerings? Data analysis types. Below are major data analysis types. We will talk about these in the coming slides. Descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. Data analysis, descriptive analysis. The goal of this kind of analysis is to answer what is happening. It uses historical and current data to show what has happened in the past and what is happening now, both with the company's data and with surrounding landscapes, including competition. It shows trends and patterns in data. An example would be Amazon finds that all items are being shipped very late in the past week. Diagnostic analysis. This analysis tries to provide the details on why is it happening. Once your descriptive analysis shows that something negative or positive happened, diagnostic analysis can be done to figure out the reason or reasons behind it. It provides the connection between the data and the trend and tries to find out what factors are driving this trend. And an example of a diagnostic analysis is continuing out to a previous example of the delayed shipment in Amazon. Diagnostic analysis finds out that some automated robots are shut down in the warehouse, leading to the shipment delay. The next type of data analysis we're going to look is a predictive analysis. This analysis shows what is likely to happen. And as you can probably guess from the name predictive analysis, you're going to predict what's going to happen in the near future based on trends you see in the current analysis. You use insights from descriptive and diagnostic analyses. Extend the trend from past data to create a forecast or predict the outcome. For example, the shipment will continue to be delayed for the next 3 weeks is one of the predictions you can make based on data from your diagnostic and descriptive analyses. It is the most useful analysis for companies. It helps create future plans and direction for the companies. It involves advanced techniques of machine learning to come up with solutions for desired outcomes. It requires lots and lots of effort and resources as it combines insights from all the previous analyses. And when you do this on a much larger scale with huge databases, it'll take up a lot of resources and power to create a proper prescriptive analysis. Here's some notable examples: the tracking of seasons with the birth of the calendar, and Moneyball. Data analysis helped create a high performing winning baseball team. Low on budget and unable to hire top players, this team used analysis of different metrics for each baseball player, including how players will play along with each other to identify bargain players and build up a team with them, which then went on a 20-game win streak. Moneyball is a great book and equally great movie showing the power of data analysis to achieve great things. Data analysis tools. Data analysis requires a combination of tools you working together. In addition to databases and SQL, some popular tools are listed below. However, there are many others in use too. Some notable examples are Excel, Java, Tableau, Python, R, etc. Okay, data types. Data collected for analysis can be grouped into the following types: structured data and unstructured data. Structured data is the first type of data we're going to look at. All data components are formatted to a set structure and formatted precisely into defined fields. Most of this data is stored in a relational database. It is searchable and easily queried with languages such as SQL. Different systems and algorithms can utilize data without much effort. It is easy to comprehend for analysts. There are more tools that have been tried and tested in using and analyzing structured data. It is easy to integrate with new or external data sources as well. An example would be any inventory management system, library, bank, reservation system, or Uber. Data types. Unstructured data. Data is in its native format. For example, doc, XLS, PDF, JPG, JSON, etc. Surveillance photos and videos, emails, PDFs, social posts, tweets, Internet of Things, sensor data, satellite imagery, etc. Data needs to be cleaned up and transformed into searchable form. Faster accumulation rates. There is no need to predefine the data, which means it can be collected quickly and easily. It takes more time to analyze this data, however, as we need to understand the data structure first and then extract the needed information before finally transforming it into work with our other data sets. Specialized and limited tools are needed to process this type of data, and it cannot be easily grouped, aggregated, or searched. Data size. Data size has increased exponentially in the past few years. As you can see over here, the rate of volume of data quickly and exponentially increased. And as you can see in the latest virtual era, how rapidly the increase in data volume is, as you went from terabytes to petabytes to exabytes to zettabytes so quickly. And on the right of the table, you can also see different technologies and tools that grew with um, these different segments of data. There will be even more data in the next coming years with connected devices, automated driving vehicles, Google Assistant, Alexa, product reviews or social interactions, and wearable devices. And as you can see, we went through a variety of data sizes: kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, zettabytes, and yottabytes. Okay, now let's look at data analysis techniques. First, let's start off by looking at regression analysis. Regression analysis is a set of statistical processes used to estimate relationships between variables. It shows how changes to one or more variables might affect one another and how they interact with each other. For example, how might social media spending affect sales? Data analysis techniques. Cohort analysis. Cohort analysis is used to break a data set down into groups that share common characteristics or cohorts for analysis. This is often used to understand customer segments. An example, e-commerce companies or digital advertisement companies can choose to show one version of advertisement to one set of customers and another version to different set. Cluster analysis. This analysis classifies objects or cases into relative groups called clusters. It can be used to reveal structures in data. For example, COVID spread analysis can highlight areas with high rates of infection. Insurance firms might insurance firms might use cluster analysis to investigate why certain locations are associated with particular insurance claims. Time series analysis. This technique deals with with time series data or trend analysis. It is frequently used for economic and sales forecasting. Time series data means that data in a series or of particular time periods or intervals. Examples: companies that provide a quarterly forecast. Big data storage. Some data simply cannot be handled by spreadsheets, notepads, or any simpler applications because of simply the sheer amount of data needed to be processed. These types of data need specialized systems to store and process this large amount. And some examples of services that handle such large amounts of data are Amazon Web Services, Oracle Big Data, Teradata, Hadoop, and Apache Spark. Data analysis. Case 1. Let's say we're at a small store in the Krusty Krabs, and at the end of a hard day, SpongeBob and Squidward can recollect from memory all the sales and determine the profit or loss inventory, and can record it in a matter of just a few pages. For example, after the Krusty Krabs closed on this date, 7/14, the item was Krabby Patty and another patty. Quantity was 5 and 10, and their profit was 10 and 15. All of this is just based on their memory. However, let's say we're at a big company like Walmart or Amazon that have millions of transactions, including sales, returns, etc., across hundreds of stores. There is no way that at the end of the day, an employee is simply going to recollect from memory all of these transactions and write it down on a piece of paper. You simply cannot record these transactions locally and straightforward. Data retrieval. You cannot review all transactions. The list is simply too big for any application to handle. You need mechanisms to query and aggregate the data. For example, SQL. Data aggregation. You have various things you can do with data aggregation. For example, sum to find the total profit or total sales, total revenue. Average, which is a number of visitors that come to Krusty Krab every day on average. Rank, which products are performing better. Year over year, how the store is doing compared to the prior year. Month over month, how the store is doing compared to the prior month. And median, what quantity is being ordered most frequently. Data review, pivot table, a very useful and powerful tool to look into data from different angles. Data visualization. It is a process of describing information and findings through visual rendering. It showcases data in a way that the human brain can easily absorb. For example, on the left, you can see a table with a vast amount of numbers and lots of information that would simply have no meaning just by looking at it. However, if we take all this information and plot it onto, let's say, a bar graph or a map or a histogram, then as you can see on the right, it's much easier to notice trends or notice patterns that we can take action upon. Data visualization. A visualization is worth a millions of data points. A dashboard as shown below can be used as a digital cockpit. The information here can be easily understood and lead the user to focus on the needed area and guide the company in the right direction. Next, let's look at scatterplot, a type of data visualization. The first step of any data analysis is a scatterplot. It shows relations between two variables. Outliers can easily be identified, and the plot shows the more time you've spent on a game, the more points you will score on the right. As on the vertical axis, we have the points scored per game, and on the horizontal axis, we have time played in minutes. And as you can see, we have a direct correlation between both. And you can notice two outliers circled in red at the bottom that simply don't match the pattern that is noticed. And this data only took us a couple of seconds to notice a trend or pattern in. Whereas looking at the table, who knows how many minutes, hours, or if we would even notice any patterns by the end. Data visualization, best practices. Speak to a specific audience. Creating nice visualizations and putting them together in dashboards is not just an exercise in providing information to the masses. This is a case where one size does not fit all. We need to know who the visualization is for and what their end goal is. It should alert the viewer of any outside the norm activity. Best practices. Choose the right visual for the purpose. The chart type must be selected carefully. For example, tables can show a lot of information in a structured way, but may overwhelm users who are just looking for high-level trends. Line charts track changes over trends over a period of time and show the relationship between one or more variables in each chart or purpose. Depending on the goal, data analysis, and the data available, and the audience type, the chart type must be chosen so that it is actionable. Provide context. It builds trust, which leads to action. An excellent data visualization technique is to help demonstrate the performance would be the use of colors, arrows, text, or any other visualization cues that would help the viewers see or glance, just interpret the information and charts shown in the dashboard. Not only will users need to see the chart and the outcome, but they need to feel comfortable using those. The chart must provide a clear and concise way of providing the information that leads to the outcome. Keeping visualizations and dashboards simple and digestible. Too much of anything becomes toxic. Same logic applies to visualization. Keep the dashboard simple enough to convey the message in a glance. Users should be able to quickly understand a high level overview of information and should have the ability to dig deeper if needed. Don't clutter the space with unnecessary and complex information. It is very helpful in understanding data if the data set is new and not enough information is available. And on the right, we can see different types of correlations. On the top left graph, we have a strong positive linear correlation. As you can see, most of the points on the scatter plot are following a simple trend, a straight line trend. Then on the top right, we have a moderate negative linear correlation. So as you can see, overall, it's following a negative, up a line with a negative slope. However, it's not a very clear or strong correlation as it's very wide and spread apart. And for the same x coordinate, there's a range of y coordinates, and that applies throughout the graph. Then on the bottom left graph, you can see no relationship as there seems to be no trend between the x and y axes. And then on the bottom right, you can see a strong nonlinear correlation. As you can see, it follows something that looks like maybe a negative quadratic equation, and most of the data is pretty close together, close to the line. Next, we could look at a bar plot. You could have a stacked bar chart, and in this case, we're comparing different consoles with the top 10. Over here, we have a bar plot with the top 10 best-selling video game consoles of all time. And what we're comparing is different regions. So as you can see, for example, the Nintendo DS sold a lot, the most in North America. However, their sales in Europe is similar to the PlayStation 2. They sold really little in the rest of the world, but they also have a lot of sales in Japan. But overall, you can easily tell that the Nintendo DS has the highest sales. And one for you can make so many conclusions from just one bar plot, like the few I just listed. And another valid conclusion would be even though the Game Boy is third overall, it appears to be first within Japan, and that's a valid takeaway from this graph. And as you can see, we have so many different analyses or so many different ways we can interpret just one graph, which shows how versatile and useful they are. Next, let's look at a pie chart. It shows a fraction of a whole, and it is used to compare different categories. For example, this pie chart shows the reasons for ending a Monopoly game, and this really small region of the whole shows the very few times that the game ends and someone wins. This slightly larger red region shows everyone quitting after 3 hours, and the majority of the time it shows somebody flipped over the board in rage. Now we can look at a time series chart, looking at activities over time. There are two components: the trend, the overall sales is increasing, or seasonality. For example, every December, sales go up and then it comes back down. And over here, we can see us comparing the trends of different sales in a time series chart. We have the Xbox 360 represented in blue, the Wii represented in red, and the PlayStation 3 represented in yellow. And as you can see, that is a valid conclusion that every December the sales go up and then it comes down. And then you can also perform other analyses on that and try to find out reasons for that. For example, a lot of people might be buying gifts for Christmas or the holiday season, which could be a possible explanation for that jump. Data visualization map. This shows the COVID spread across the country. And the darker the color is, the closer it is to dark red or brownish, the more dense the COVID spread is in that area. And the lighter the color is, the closer it is to yellow or white, the lesser the COVID spread is in that area. So as you can see, this makes it much easier to identify major hotspot regions. For example, in the Northeast or in the South over there, right of Texas, etc. And those were just a few types of data visualization charts, but there are a lot and lot of other types of data charts. For example, donut charts, candlestick charts, Sankey charts, and funnel charts. Um, so here's some data visualization tools that are commonly used, each having their own pros and cons. We have Excel, Google Sheets, Tableau, Click, scripting in R or Python. Let's look at some tool features. Features are of good visualization tools are as follows. Ability to handle large amounts of data, for example, greater than 1 million records. Ability to merge data from different sources. Control who can see what. Data security. Must be able to refresh the data and visualization at some frequency. Show a dashboard with multiple visualizations grouped together. Provide ability to interact with the dashboard, such as data filtering. Supports supported many chart types. Data visualization on Tableau. Can connect hundreds of data sources and types. Excel, CSV, MySQL, Oracle, Teradata, Hadoop, Amazon, etc. Free versions are also available for testing, and they have a big community support, so you can get answers to most of your questions with the large community that's willing to help. Lots of tutorials are also available online, some for free and some paid courses. It is extremely fast and efficient in creating charts, and it has a very simple interface with a drag and drop option to create many visuals, including data tables. You can easily change from one chart to another as well. Okay, now let's look at live examples. Let's start off with the pivot table in Google Sheets. Okay, I just shared my screen to Google Sheets, and right now we're going to be doing a live demo on how to create a pivot table on Google Sheets. So as you can see over here, I downloaded a bunch of sales data with lots of different columns such as order ID, order date, customer ID, etc. And in those fields, they have the corresponding information. And as you can see, we can't really see any direct trends just simply by looking at this vast amount of information. So now we're going to start creating our table. First, let's start off by adding a new sheet. We're going to go to Insert, or we're going to go to Data, and then we're going to go to Insert and click on Insert Pivot Table. And now we're going to select the data range to create a data table from, for which we're going to go back to our data sheet, and let's select all of these rows and put it into an existing sheet, and we'll link it to the new sheet that we just made. And we're going to click Create. And as you can see, it just created an empty table as of now. And on the right, we have all of the different fields or columns that we have that we can drag and drop. So let's say we drag and drop segment into the rows section of the pivot table. As you can see on the left, we have the different segments on each row. Now let's say we drag profit to columns or values. Then now, as you can see, we have the sum of total profits for every segment. And then we could drag country into columns. And now as you can see, it is sorted by segment and country with each of their corresponding profits. And we could put ship mode in columns and replace it. And now once again, it's sorted by segment and then ship mode, which includes first class, standard class, second class, etc., with all of the totals included as well of profit. So by using this technique, we can simply rearrange all the data, rearrange all the columns, and look at different like we could sort the information different ways that we want. We can do different math operations such as sum, average, median, min, max, etc. Things like that, and visualize the data in different ways. For example, I clicked on count, which just gives us the total, the number of values in every single field, the corresponding fields. Or we could just drop subcategory into row. So now it's gonna sort by segment, but within each segment, it'll have all the subcategories sorted out as well. And then in each column, of course, we have the ship mode. So as you can see, you can simply just rearrange the same table and focus on different columns or different data types. And now, if we go here to region profit, as you can see, we have different states and categories that are all connected together with profits in each value. And we have made a graph over here at the bottom. As you can see, we have plotted these on a graph, which makes the trends much easier to analyze. As you can see, we can easily tell that New York had the most profits in yeah. And then another example is this time series chart where we have the months and then sum of profits in those months. And as you can see, on average, we could predict that in July the profits would go down, in September they would peak, things like that. So they would have a loss overall in July and high profits in September, which also is reflected on the table. And then we could also put order date in the rows to simply sort it by different order dates. Oh, and we could also add some filters to refine our data. So for example, if I put customer name in filters, we could remove all customers and simply only select Aaron Bergman. And now our final data only returns results based on order date and ship mode of only Aaron Bergman and no other customer. Or we could do other filters. For example, if we want to focus on a specific state, we could filter out only California. And now this data is the resulting data only of California. Okay, that was it for the Google Sheets demo. Now let me try to set up a Tableau demo. Okay, I'm now sharing my screen on Tableau Public. So as you can see on the left, we have a lot of tables with categories, city, country, customer ID, etc. So let's drag state and put it into the rows section over here. It looks like we're having some problems with Tableau Public, so I don't think we'll be able to do the demo, so we'll just move on with that. Okay, next let's look at forecasting. One of the many goals of data analysis is to provide forecasting. As you can see, based on this scatter plot we have here, we can make a line of best fit after looking at that trend. And based on the line of best fit, we can predict that this pattern will continue to happen in the near future and forecast these red dots. That's a prediction. Once again, yeah, forecasting line of best fit. Linear regression creates a line of best fit. And y equals mx plus b represents the equation for the line. And best fit tries to minimize the error or deviation from all the scatter points. So as you can see, the line of best fit doesn't actually have to go through all the data points. It's just a line where the distance between each data point and the corresponding point on the line is over all the least. Then we have nonlinear regression. Not every line of best fit follows the equation y equals mx plus b. It can have curves or it can be much more complex. Most of the time, the line may not represent a straight line may not represent the trend properly. And in these cases, we need to use nonlinear regression. For example, over here, as you can see, our data peaks at around 140 and goes down on the left and the right in this manner. So a linear line of best fit would not be the best choice. So we're going to use a much more complex line of best fit that better represents the data. Data analysis caveat. Correlation versus causation. You can do a correlation analysis on any two data points, but they may not necessarily impact each other. Example, correlation between ice cream sales and sunglasses sold. As the sales of ice cream is increasing, so do the sales of sunglasses. But sunglasses does not directly cause ice cream sales to go up. Causation takes a step further. It says any change in value of one variable will cause a change in value of another variable, and it also references a cause and effect. For example, when a person is exercising, the amount of calories burning goes up every minute. The former is causing the latter to happen. Confirmation bias. A confirmation bias results when researchers only choose data that supports their own hypothesis. Data scientists exhibit confirmation bias when they actively seek out to assign one or more weight to evidence both confirms their hypothesis and ignores and underweighs evidence that could disconfirm or go against their hypothesis. Researchers needs to be very careful as given a large amount of data set, it can tell you anything you like. Advanced data analysis. Text analysis, customer reviews and tweets. Sentiment analysis. Helpful for marketing outreach, politics. Deep data mining. Explore and find data that is not directly visible or expected. Machine learning, neural networks, and AI. And here's some other examples of data analysis. The words they used, good use of bubbles and table, to convey the information. As you can see, the bigger bubbles include words that are used more often, smaller bubbles are less often, and that's just a great way to represent this type of data. Another example of that is military spending by country. As you can see, the bigger the circle, the more the military spending. And you can easily tell from this that the US spends the most of the military. Coming after that is China, and etc. Over here, you can see the bar graph showing the average global temperatures compared to the middle of the 20th century. And based on this, once again, you can see a very obvious increasing trend as time go in recent times. As time goes on, the average temperature is also increasing. And over here we have the mystery of the bus riders. As you can see, overall, once again, after some point in around 2016, the the average bus riders in all four of these cities consistently declined. And then we have advanced techniques of data analysis, such as machine learning with Google Assistant and Siri, artificial intelligence in self-driving cars and intelligent machines, and data analysis in the near future. By 2023, the industry of big data is expected to be worth 77 billion approximately. 94% of enterprises say that analyzing data is important for business growth and digital transformation. Companies can exploit their full potential of their data and increase operating margins by 60%. Data analysis, next steps. Kaggle.com has lots of free real data sets to play with. It also has lots of scripts for machine learning and data analysis that you can experiment around with. Tableau Public creates easily visualizations. You could, and I have linked Tableau Public right here, public.tableau.com. And there's also this Reddit for some good data visualizations, and this New York Times article that is pretty interesting. And this is the end of our webinar on data analysis. You can reach out to me at dhruv.rai@hsnavigator.org, and also feel free to connect with me on LinkedIn. I put my LinkedIn over here. If you guys have any last second questions, feel free to put it in the Q&A, or you could reach out to me at the email I provided. And thanks for attending. Have a great day. And sorry we couldn't get to the Tableau live demonstration, but like I've linked it so you guys can just experiment around with it on your own.